Hello, this is JP from Justice Prep, and these are the math explanations from the official ACT Prep Guide Test Number 1, or MC1. Let's get right into it. Number 1 is an algebra question, and we're dealing with algebraic expressions. Which of the following expressions is equivalent to a times the quantity 4 minus a minus 5 times the quantity a plus 7? The first thing I want to do is rewrite this, and as I rewrite this, I'm going to put the negative a first, and then the 4 second in this expression, and then negative 5 times the quantity a plus 7. At this point, what we need to do is distribute. I'm going to do a times negative a and a times 4. That's negative a squared plus 4a. And then negative 5 times a and negative 5 times 7. That's minus 5a minus 35. Here we have like terms, so we're going to combine them. That's minus 1a minus 35. And so the answer will be C. Number 2 is a number and quantity question. We're working with fractions and decimals. Which of the following inequalities orders the numbers 0.2, 0.03, and 1/4 from least to greatest? What we can do first is convert this 1/4 into a decimal. 1/4 is 0.25, and so let's take 0.2, 0.03, and 0.25 and put them in order from least to greatest. This is going to be your smallest, and then 0.2, which is really 0.20. That's a 20, that's a 25. The 25 is going to be bigger. So that will be our order. The 1/4 is going to be last, and 0.03 is the smallest. G is our answer. Number 3 is an algebra question. We're solving equations. If x squared plus 4 equals 29, then x squared minus 4 equals. I'm going to first write this out. We can do this a couple of ways, but what I want you to notice is what the difference is here. How do we get from a plus 4 to a minus 4? Well, what we can do is we can subtract 8. X squared plus 4 minus 8 is x squared minus 4. That's how we get to x squared minus 4. So what we can do is subtract 8 from both sides. If we subtracted 8 on this side, we can subtract 8 on this side. What we get is 29 minus 8, which is 21. This is our answer. Now you could have done this in a couple more steps. You could have subtracted the 4, and you would have gotten x squared equals 25. So then we can substitute that 25 into the x squared, and we get 25 minus 4 equals 21. Number 4 is a geometry question. We're dealing with area and percents. The vertices of a rectangle are -1, -2, 4, -2, 4, 3, and -1, 3. When the rectangle is graphed in the standard xy coordinate plane below, what percent of the total area of the rectangle lies in quadrant 3? The first thing we can do is plot these points. And what we end up getting is a 5 by 5 square. So although this says that it's a rectangle, it's actually a square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are actually 25 of these 1-unit blocks inside of this square. And since we're looking for percent, I'm going to put that on the bottom of my fraction. How many of these 1 by 1 unit squares are in the third quadrant? 2. So this is 2 out of 25, which is the same thing as 8 out of 100, or 0.08, or 8%. F is our answer. Number 5 is a functions question. We are working with arithmetic sequences. In 1985, the cost of clothing for a certain family was $620. In 1995, 10 years later, the cost of clothing for this family was $1,000. Assuming the cost increased linearly, what was the cost of this family's clothing in 1991? The word linearly is important. It means that things are increasing at a constant rate. We first have how much they spent in 1985, and then we have how much they spent in 1995, 10 years later. That means that each year we're increasing at the same exact rate. And we can do this several ways. We can set up an equation, $620 plus X amount of dollars times 10 years has to give us $1,000. So we start with $620 in 1985, and each year we're going up by an X amount, and we're doing that for 10 years, and that's supposed to give us $1,000. If we solve for X, we get X times 10 equals 1,000 minus 620, which is 380, divide by 10, and we get x equals 38. That means each year we are increasing by 38. This means that 1986 would be 620 plus 38, which is 658. We're going to add 38 each year, and we have to get to 1991. So what we can do is we can start with 620, and we multiply 38 by 6 years. That will get us the right answer, and that is 848. The answer here is B. Now, we could have done this slightly differently. We could have thought about this as an average. So if we have 1,000 in 1995, we're going to subtract what they were spending 10 years ago and divide that by 10. That's going to be 380 divided by 10, which is 38. That gets us to the annual increase fairly quickly. And then we're going to do what we did last time, which is start at 620 and add this 6 times, which will give us 848.